Hello, ladies and gentlemen. Welcome to Physics 30, Electromagnetic Radiation, EMR, Lesson 2, Speed of Light. Now, a few things before we get going. Now, speed of light is the fundamental constant of the universe. It's the upper limit of all speeds. Our best measurement of speed of light is 2.99792458 times 10 to the 8 meters a second. However, normally we talk about it as 3 times 10 to the 8 meters a second in a vacuum. Now notice I say in a vacuum because the speed of light can be slower than that. And we will talk about that later. But right now we're just measuring speed of light. How do we do it? Well, Galileo, the ace of spades, attempted to measure the speed of light, but was too fast to be timed by his pulse. Now Galileo, a very famous scientist and artist, he made measurements and he recorded his data. He was one of the first people to do that. Many people have done experiments before, but if you don't take careful measurements or record your data, we don't know about it. So what he did was he had an assistant stand on a mountaintop and he would open a lantern, and the light would travel to a servant on a mountain about a mile away, or 1.5 kilometers. When the servant saw the light, he would open his lantern, and the light would come back to Galileo. Now the trouble was, he only had his pulse. So if you think about it, speed of light is 3 times 10 to the 8 meters per second. So, I'm sorry, this distance was about 2 meters, about a kilometer, 1,000 meters. So, velocity is displacement over time. Rearranging that, time is displacement over velocity, which is there and back, 2,000 meters, note that, divided by 3.0 times 10 to the 8 meters per second. He's measuring something 7 to the minus 6 of a second. Something like that. 2/3, 6.6 rounds off roughly 7. There's no way you can do that with your pulse. A good attempt, but it didn't work. Now, one of the first measurements of the speed of light, or one of the first accurate measurements, relatively, was by Olaus Rømer, 3 of diamonds, and Christian Huygens, 9 of diamonds in the 17th century. Once again, if you're one of my students, you know I've printed off a set of cards, 52 cards. Each one of them is one of the scientists that you're supposed to know about. So, Olaus Rømer is 3 of diamonds, Christian Huygens is 9 of diamonds. If you're not in my class, email p.sutton@hpsd.ca and I'll forward you a set of cards. Now, anyway, Rømer measured the times at which the moons of Jupiter disappeared behind Jupiter or ellipsed. Now, if you note here, what happened, when the Earth was far away from Jupiter, position B, he noticed the ellipse was 22 minutes later than the predicted time. 22 minutes later than predicted when the Earth was close to Jupiter. So we go back to the drawing here. When Earth is close, this ellipse of the moon going behind Jupiter happened at one time. 6 months later, the moon traveling behind Jupiter would go like that, and there was a time difference of 22 minutes. What's the difference here? Well, it's the distance, let's do it this way, the orbit of the Earth. Now, Huygens concluded that the light from the moons needed more time to cross the diameter of Earth's orbit. This gave them a calculation: speed of light, distance across Earth's orbit divided by the time to cross Earth's orbit. Now, using the size of Earth's orbit, he calculated the speed at 2.1 times 10 to the 8 meters per second. Is that 3 times 10 to the 8 meters a second? No, but it's the first good one, and I can't argue with him. Now, somewhere in there was something wrong with not the calculation, but anyway, they didn't quite get it right. A man, Phys, 6 of diamonds, used a toothed wheel to measure the speed of light in 1848. He measured speed of light C to be 3.15 times 10 to the 8 meters per second. Now, this is getting quite good. Now, what he did here was a light source and a mirror. Actually, I should color code this. Light source and a mirror. The light would go down, hit the mirror, go through gap in the teeth, hit a mountain. I forget how far away it was. You can Google this. Actually, in the Google Classroom, I put on a video on this from one of the Mythbusters, and he talks about this. The light comes back between the teeth, and the observer sees it. So the tooth wheel has to be spinning at a certain speed for the light to go between one gap and come back between the next gap. Now, is this perfect? No, but is this bloody good? Yes. Good luck trying to measure that with your pulse. Now, the first accurate modern measurement was by Albert Michelson, 7 of clubs. I haven't found a good video on him yet because he did a far more famous experiment on ether, and I'll talk about that later. Anyway, 1926, he found the time needed for a beam of light to travel from one mirror to another and back. Now, it's important. So you have the light source. So the beam of light hits the mirror, reflects off, hits a stationary mirror 30 kilometers away on a mountain, reflects back, hits the mirror again, and reflects into your eye. The light detector, which is your eye. Okay? In theory, fairly straightforward. An impressively complicated lab to set up. If you do some digging on this, you realize he had dug a tunnel and it was in a vacuum, and wow. Anyway, way too much work. Now, light from the source hits the rotating mirror, bounces to the fixed mirror, is reflected to the rotating mirror, and was reflected back to the rotating mirror and then into the observer's eye. Now, the big thing here that gets most people is in order for light to reach the observer, the mirror must make 1/8 of a rotation. So that means this mirror is rotating. So this side was here, but it's rotating this way. So what happens is this mirror comes to here. And it must be exactly there for it to work. If the mirror is going a little too slow or a little too fast, the light doesn't hit at the right angle and you don't see it. So it has to be, the mirror must be making 1/8 of rotation, 8-sided mirror. You'll see questions where it's a 10 or a 12-sided mirror. Now, if the 8-sided mirror was rotating at the proper frequency, one side of the rotating mirror would be in the proper position to reflect the light into the telescope. All right? So it had to be rotating at just the right speed. Now, if the fixed mirror is 35 kilometers from the rotating mirror and the 8-sided mirror is turning at 32,000 RPM, calculate the speed of light. Now, this is a typical diploma question. Okay? So, first things first, velocity is frequency times wavelength, the universal wave equation, which is also wavelength divided by the period. Now, going back to our drawing here, it was set up like this. I've changed the numbers. Pay attention. So you've got the 8-sided mirror, and it's 35 kilometers away. So, eight-sided mirror, light ray into your eye. Color code this. Fixed mirror. This is 35 kilometers. 35,000 meters. Kilo means 1,000. All right? And this mirror is rotating. All right, so far so good? So, velocity is frequency times wavelength, or wavelength divided by period. Now, here, my apologies. Velocity is displacement over time. That's the other formula we should use for velocity. Now, I know my displacement is 2 times 35,000, or 70,000. What's my time? Well, here, what do I know? Well, what is the other number I haven't talked about? 32,000 RPM. What the hell is that? I mean, heck is that? Well, don't be that guy. 32,000 RPM is revolutions per minute. Now, divide by 60, we get 533.3 revolutions per second, or 533.3 hertz. Woohoo! We have a frequency. Now, what is your issue? Stop that. Period is 1 over frequency. So the period for this is 1 over 533.3 hertz, which gives me a period of roughly 0.00, Mr. Calculator says 1875 seconds. All right, now, so far so good. Now what's the trick? Well, it's an 8-sided mirror, so it's 1/8 of a rotation. So the actual period is 1/8 of this, which is 2.34 times 10 to the minus 4 seconds. Okay. Now, here we're going, what's the speed of light? Now, grab Mr. Calculator. As I can't read my own writing, 70,000 divided by 2.34 exponent to the negative 4 is 2.99. 14 times 10 to the 8 meters per second. Now, this is a popular sort of question on the diploma because they will fix the data so you don't get 2.9, you don't get 3 times 10 to the 8. You get like 2.8 or 3.1, which is wrong. You and I both know it's wrong, but they'll catch you if you automatically say 3 times 10 to the 8. All right? Sort of kind of see that? I did that one kind of quickly. I'll do one more a smidge slower. Come on, next page. Now, an 8-sided mirror is rotating with a frequency of 600 hertz and is located 30 kilometers from a fixed mirror. If you see the returning light, what is the speed of light? All right. Velocity is frequency times wavelength, which is wavelength over period, or velocity is displacement over time. You have an 8-sided mirror. Sorry about that. Where was it? Oh, yeah. So the light is going down here, reflecting out, coming back, and hitting in your eye. So this distance is 30 kilometers, which makes it 30,000 meters. So your displacement is, it's twice as far. Don't make that beginner's mistake, Mr. Sutton, when people are watching. They enjoy laughing at you. Behind your back, 60,000 meters divided by your period. Now, what's the period? Well, here this is easier. Frequency, 600 hertz or 600 cycles per second. So the period is 1 over the frequency, or 1 over 600 hertz. And I can't do that in my head. Where's Mr. Calculator? All right. Zero 166 repeating. Let's not do any rounding off yet. Seconds. Now, and the trick is, yes, it's an 8-sided mirror. The other black 8-sided mirror, which means divide all this by 8. Not the frequency, the time. 1 complete rotation, but you're dividing by 8. Now be careful. I have seen 10-sided and 12-sided, but Michelson used an 8-sided mirror, so that seems to be a popular number. Just is. Be prepared to see it different. Now, you calculate the time here, divide by 8, and you get is 2.083 repeating times 10 to the minus 4 of a second. 2.83083 repeating times 10 to the minus 4 of a second. That gives me a velocity. Velocity is 2.88 times 10 to the 8 meters per second. Now that is a typical diploma question. Velocity, that is an incorrect number. Somebody made a mistake, but they will nail you if you say 3 times 10 to the 8 meters a second. multiple choice question, that would be B or C. A is 3 times 10 to the 8. Don't fall for that mistake. All right? Now, give this a try. There is a lab to go with this. I'm going to try to do that as a demonstration if I can get a web camera that works. Anyway, so good luck. Give this a try. Check your understanding, sorry, your homework for lesson 2. We'll talk about it in class tomorrow. Good luck.